I don't want to topple the whole camera, right? I fat white, Joshua, huh? I fat white. See it, see it? Wow. You caught your 4K there.
Okay, let's start, shall we? Okay, so yesterday we were looking at derivatives of logarithmic functions. Okay, we have covered how to actually go about differentiating it already. Okay, then yesterday I asked you to go back and get certain questions done. Okay, and those questions for question 1A, 1B, C, D, 7A, B, F. Okay, we'd like to do a quick check, okay, whether any of these problems is an issue. Question 1A, any problems in doing it? I assume that you have done it and then you have also checked your answers, the answer will get back as well. Okay, so 1A, any problems? 1B, okay, I wouldn't expect much problems for 1A and B. How about 1C and 1D? Okay, then I am assuming problems in question 7. Okay, 7A, BF, 7A any issues? Okay, 7B, 7B no issues. Okay, 7F. Alright, so I'll just go through 7A, B and F. Okay, so for question 1, A, B, C, D, if you have separate issues, please let me know. Okay, so we let y to be equals to 3x ln square root x squared minus 2x minus 3. So what we will do is that, okay, you could simplify this by saying that the ln itself, this function, can be expressed like that. And using our logarithmic laws, my power half can come down to the front of my logarithm, which makes it 3 over 2x ln x squared minus 2x minus 3. Okay, this is the only extent that you could actually simplify it to. There's no other ways to break out the logarithm anymore, because inside of it is all connected by subtraction. Okay, so from here we will then proceed with differentiating, and we have to do our product move by recognizing the two products, 3 over 2x and the logarithm. Okay, so keeping the left side, differentiating the right, I will have 1 over x squared minus 2x minus 3, followed by multiplying the differentiation of this. Okay, we can just leave it on the numerator, that will be 2x minus 2. Okay, so that is for the left side. Now to the right side, we add, keeping the right side, and then followed by differentiation of 3 over 2x, and that will be just 3 over 2. Okay. Then we tidy things up a little. You could choose to factorize out the 3 over 2, and then here we will have 2x minus 2 times x over x squared minus 2x minus 3 plus the logarithm. Okay. Alright, so this is one way that you could possibly leave the answer. Alternatively, okay, you could also consider that the 2's here cancel each other out, because you can factorize up to 2 and divide by 2. So you could actually also leave the answer as 3x x squared minus 1 over 3x over x squared minus 2x minus 3 plus 3 over 2 logarithm. Okay, so multiple ways that you could leave your answer. Right, either you can factorize out 3 over 2, or you want to just simplify it to this extent also can, they are equivalent. Okay? Okay, then in 7b, to differentiate y equals to ln sin x times cosine x, we first use our logarithm laws by splitting up the logarithm into 2 parts, ln sin x plus ln cosine x. Okay, then we do our differentiation, where we have 1 over sin x, followed by the differentiation of sine, that will be cosine, and then differentiating ln cosine x will be 1 over cosine, followed by the differentiation of cosine as negative sine x. Okay, then you know your trigo function, cosine over sine is your cotangent x, negative sine over cosine, that will give us minus tangent x. Okay, so that will be the most simplified answer that you should achieve. Okay. Questions? For part F, it's a forward or not. Okay. For part F, again, simplify the logarithm. Okay. If you are very familiar with logarithm laws, you can do it in one step. Okay. But then, let me just break it down step by step. So, as ln of the numerator minus away ln of the denominator. Okay, then further breaking this product out. Okay, then you can bring this power down. So only in this extent that it is much easier for us to go about doing our differentiation. Yeah.
Can I ask, for that portion of it,
The what?
when you're cancelling portion, how come like you get to 3x and then it's x minus 1? Because you cancel 2 and you have x minus 1.
3x minus 1. Oh,
Will it be?
Is it in doing this, right?
Yeah.
Yeah, sorry, my bad. Should be 3x times x minus 1, right?
Thank you.
Yep. Yeah. Sorry? Which one are you talking about now? F, Oh, too many minutes. Thank you. Sorry. Okay. Alright, any other questions? Okay. If not, then I'll go into the application part. Okay, of the logarithm functions, yeah? Yeah. Tangent 3xi. Sorry. Thank you. Okay, sometimes I think faster than I write, so that's why it's not being happened. Okay. Any other mistakes that I might have made? Yeah. Okay. Now let's go into, let's do tritone first, okay? Right? Let's get try 10. Okay, going back to something that we should be familiar with, our tangents and normals. So in the very first question, or rather the start of the question, it says that the curve goes by this equation, y equals to ln x e power negative 2x minus over 3 minus x to the power of 3. Okay, we want to find the gradient at P at a certain point, and at that point our x coordinate is 3. So we need to first find out what is our derivative. So given this, our dy over dx will be 1 over whatever function that we have, and then if you want you can do your product rule, but you realize that it is challenging. Okay, so what will be better is that since it is a product, you can simplify that first. You can write it as ln x plus ln e to the power negative 2x minus over 3 minus x cubed. Okay, then with the ln e, you can break down the power. That will give us minus 2x, and ln e itself is 1. And then we get this. Okay, arriving at this will be easier for us to differentiate. Okay, so we arrive at this. Okay, since you're looking for the gradient at x equals to 3, your dy over dx will be equals to negative 1 and 1, or 1 and 2. Okay, therefore the gradient at P will be negative 1 and 2. typical question is to know how to answer part 2. Part 2 says that there's a normal at to C at P that meets the y-axis at A and the x-axis at B. So to understand this question itself, you may wish to draw a diagram. Okay. I honestly do not know how this graph looks like, so I'm just going to draw a random curve. Okay. I don't even know whether this curve works. Okay. Then after that, we know that point P is when x equals to 3, so let me call this point P. Okay. We know how to identify the tangent. Maybe my tangent is not well drawn. Okay, so let's this P, x equals to 3. But we're not talking about the tangent, we're talking about the normal. So for the normal itself, it will be perpendicular to the tangent. Looks like this. Okay? And the question is saying that this green line, this normal, cuts the y-axis at A. Y-axis is not long enough. Let me just extend it. Okay? So it cuts the y-axis at a certain point A and cuts the x-axis at a certain point B. Okay, so now that we have the diagram, it's much easier for us to visualize it. Okay, and then we want to find the area of the triangle OAB, and the area would then be O is referring to the origin. The area we're looking at is this. Okay. Then my normal itself does make sense to the question since we know that the gradient of the okay, it doesn't quite make sense, right? Yeah, because the gradient of the tangent is supposed to be negative, but it really doesn't matter. It's just for us to get the understanding itself. Okay, how it's supposed to look like. Okay, so find the area of triangle OAB. Okay, so to find the area of the triangle OAB, I need to know what are the 2 points A and B. If I don't know what are the 2 points, then I wouldn't be able to find out the area. Okay? But before I can find out what is A and B, I must know what is the equation of the normal. Okay? If I know the equation of the normal, I will then be able to sum x equals to 0 and y equals to 0 to find out what is A and B. So to find out equation of normal, I must have the gradient of the normal. So gradient of normal will be negative 1 divided by negative 1 and 2 over 3. That will give us 3 over 5. Okay. Then we need 1 point, which is the coordinates of P. So when x equals to 3, the coordinates of P, the y coordinates specifically, will be ln 3 times e to the power negative 2 times 3 minus away 3 minus 3 cubed. That is ln 3 e to the power negative 6. This is 0. Okay. So therefore, equation of the normal would then be y equals to mx plus c, y equals to 3 over 5x plus c. Using the point that we have about p, that will be ln 3e negative 6 equals to 3 over 5 times 3 plus c. So c equals to this, and our y will then be equals to this. That will be the equation of the normal. have the equation of the normal already, I can find out what are the coordinates of A and B. So to find out what is A, x is equals to 0. Okay, and y is equals to this. Then let me write down. A is 0. And to find out what is B, y is equals to 0. Sorry, I'm just squeezing all the way at the bottom. So B is 9 minus 5 log 3e negative 6 over 3. 0. Okay. So now that I have the coordinates of A and B, up to your personal preference, what kind of formula you want to use to find the area. Okay. With our diagram, it is very clear that this triangle is a right angle triangle. Hence, it will be easy for us to do half times base times height. The base will be the distance from O to B, that is the x-coordinate of B. And the height will be the y-coordinate of A. Okay? It is in fact perfectly alright if you don't leave your answer in exact for this question, since the question didn't ask for exact. So in fact, okay, somewhere when you try to find C, you want to leave it to truncated 5SF, that's also okay. You just have to take note of your accuracy consistently throughout the question. So if you want to leave as decimal, you can work with decimal values, you can. So this one you can leave it as truncated 5SF. Then the subsequent calculation all use truncated 5SF. Even up to here, truncated 5SF. Okay, final answer, then we round off to 3SF. Right, that's your accuracy practice. Okay. But I mean, I mentioned again and again, we learn how to do it exact lah, okay? As a practice. Let me think whether it's feasible if it's exact. Okay, I think this one to leave it exact will be extremely challenging now. Okay, let me move it out. Otherwise, you can just press calculator for rotating and leave it in decimal. the liters that I can leave it to if it exact. Let me just do a quick check. Is it even correct? 0.5 3 ln 3 ln 3 minus 7. No, it's not. Why? This is class. Did I make a mistake somewhere in terms of leaving it exact? Nine divided by 3, right? 3 minus. Okay. Minus 3 minus 3. Did I make a mistake somewhere? Somehow my answer is negative.
It's correct. Negative is correct.
But it should be a positive 37.4. Your best calculator?
Because the points lie below.
Sorry, one line below.
Your A and B lies below 0.
Like in the graph.
Oh, in the graph, A and B lies below 0. Oh, okay. Sorry, because that's a problem because I didn't check the decimal values. Okay, yeah. Then if A lies below 0, okay, then yeah, then should have been a negative here, right? Okay. Yeah. So then it will be a positive number because you're looking for length itself. Okay. Then everything should actually go to this already. Okay, great. Thank you. Okay, our final answer should be 37.4 in 3SM. Okay? Questions? Okay, if no questions, then let's move on. Okay. Anyway, alternatively, you could do the shoelace method for this. Okay, nothing wrong with doing shoelace method. But the shoelace method, the problem is that you must know the clockwise or anti-clockwise method. Okay, then therefore your diagram needs to be fairly accurate, okay, for us to actually know which direction is it supposed to be. Okay. Now let's look at exercise 15.3, question 6. Okay, so looking at this question, in your textbook, that's in textbook page 88. It says that the housing price index in a particular country between 2010 to 2020 was given by this function. Okay, where t refers to the number of years after 2010. Okay, what the question wants us to do is to show that p is an increasing function. For t to be between 0 to 10. Okay, so for this kind of increasing decreasing function, I know that it's always our weaker part, okay, in terms of knowing what to actually show. So I want us to be clear that to show that p is an increasing function, that means that at the end of our answer, okay, your dy over dx needs to be more than 0. Okay, so that is our aim that we're driving at. So, but in this case, we're not talking about y or x, we're talking about p and t. So please make sure you use the correct notation. So in differentiating this part, we will get 0.1 plus 1 over t plus 1. Okay? Now we want to show that this is going to be more than 0. Okay, how can we go about explaining that? Okay, so in this case, the interval of t that we're given is between 0 to 10. Okay, hence t plus 1, because that is the only part whereby there is t. T plus 1 itself will be between 0 to 11. Okay? And this clearly tells us that t plus 1 is positive. Okay? And since t plus 1 is positive, it will also be obvious that 1 over t plus 1 will have to be positive as well. Okay? And when I add a 0.1, it will be more than 0.1, which is also positive. And therefore, this means that our dt over dt is more than 0. So we conclude, okay, that p is an increasing function. Should be manageable, okay, in terms of showing that it is more than 0. Okay. In contrast, okay, let's look at question 9. Question 9, they ask for a different thing, so I'm always trying to show you two different kind of increasing decreasing function question. This one is to show that it is increasing, this one is already tell you it's increasing, and we want to find the range of values of x. So upon differentiation, we apply our quotient rule. at 2 log x. Before applying it, it will be easier. Okay, then we will have 2 minus 2 log x over x squared, because the x actually cancels out here. Okay, so we are given that dy over dx is more than 0 because it is increasing. That means that my 2 minus 2 log x over x squared is more than 0. Okay, we are trying to find the range of values of x. So the big question over here is, how do I find the range of values of x from this inequality itself? Okay, so this statement itself is telling us that this entire fraction is positive. Okay, so for us to have a fraction that is positive, it either means that positive, positive, or negative, negative. Agree? But then our x squared is already positive because we know that any squared numbers are positive. Okay, so we know that x squared is more than 0 or x more than 0 because question gave us x more than 0. So I'm just keeping it a bit. Okay, so therefore it means that my 2 log x must be more than 0. Okay. In other words, 2 is more than 2 log x. Okay. Always remember, I can only plus, minus, times, divide a number, cannot be an unknown. So I can at least now divide both sides by 2. Okay. So we're looking at an inequality that says 1 is more than log x. Okay. It is illegal for us to do square root on both sides, okay, to exponential on both sides, logarithm on both sides for inequalities. Okay, so I cannot actually solve this happily like I solve logarithm equation, right? How to actually go about solving this? We need to go back to our understanding of logarithm graphs. Okay, so your logarithm graph, this one we studied last year, okay, looks like this. So y equals to log x. Okay, then after this point here is 1. Alright? So this is the basic that you need to remember for your logarithm. Just trying to help you remember here. Okay? So this case, it says 1 more than log x. We can also see it in other way, which means log x less than 1. It means the same thing, right? Okay? So we want our log x graph to be the part whereby it's lesser than 1. So we want to know, okay, at this point where y equals 1, where is the part where your log x graph is below that line itself? So this range of values is what we want as an answer. Okay? So to find out what is this range of values, I know that surely it is 0 over here, but I do not know what is this one. Okay? So just to do a very quick calculation, when log x equals to 1, because y is 1, okay, so y is 1 here, we know that it means x equals to e to the power of 1. So in other words, this value here is e. Okay, e is a number, right? And therefore, from our graph, I conclude that, okay, my range of values of x will be between 0 to e itself. Okay, so x. Right? There cannot be equal sign over here because in our logarithm graph, it never ever touches my y-axis. It only approaches, it doesn't touch. There's never intersection. Okay, so therefore can never have equal sign over here. There's also no equal sign over here for the e boundary because at e itself, it is equals to 1 already. But our inequality is strictly greater than or strictly lesser than, depending on which one you're looking at. Okay, so we want the one that's strictly lesser, so therefore it doesn't count E inside it. Okay, hence our answer will be 0 to E. Okay, the only way is really to rely on graph, you cannot do anything else. If you go and solve, you'll never get this answer. Okay. Right? So when we did our sine, cosine, trigonometry differentiation, and we also did something similar to this, we also relied on graphs because we're dealing with inequality. So whenever dealing with inequality, okay, whereby there's a function inside it, we must rely on graphs. We cannot solve it at all. Okay, we cannot say plus something both side, minus something both side, or do something on both side. Okay, must go back to the graphs. Alright? Questions? Yeah?
You don't apply logic. I think you cancel the this side.
Okay. I wanted to do another question, but looking at it now, I think there's no need for us because we already tried that very vigorously already. Okay, so we just end our lesson here today. Alright?
Oh no.
But obviously there will be homework. Okay. Exercise 15.3. That's right here. Let me just do a quick check.
I think that thanks for watching. Remember to do your homework. And hit the subscribe button. Oh, after she assigns it. Should do panning. Follow me.
Are you zooming in on her?
No, I'm zooming into the homework.
Okay, 5 questions. Right, 4, 5, 8, 13, 14. Okay, by the way, I have already uploaded this morning, okay, a set of A-Maths practice questions for your WA2. Okay, there is no past year paper that I can send you because past year paper WA2 tests different things. Okay, so it's really a compilation of your past year questions. Alright, so I think I have 60 questions inside it, okay, for your WA2, chapter 13, 14, and 15.1. So go and practice them, okay. Then I also uploaded an empty set of your past test 1 in case anybody would like to redo it or to revisit the questions there. Okay?
Not past test one.
Yeah.
WA1.
Homework due when? Oh yeah, I just forget that. It must be my subconscious telling me I don't want you on this. Okay. Due on do you have anything on Tuesday? This is week 4, right? I mean, I recognize that you're your WAs lah, okay? Thursday? Wednesday? Thursday? On Thursday HBL? No, Thursday. Huh? Tuesday or Wednesday? Wednesday. Wednesday, Friday don't want, too long already. Okay? For what? Huh? For what? The other homework, yeah, the other homework due on Monday, right? Then due on Wednesday, is it fair enough? No? Since some of you are shaking it very badly. Okay? Okay lah, just need Friday, okay? But then, next week is E-Maths, matrices, okay, please make sure you get the SLS done. Yeah, yes.
I hate going out.
Oh.
He's listening comprehension music.
Where's the mic?
Here, just leave your prep your next lesson and probably actually this to get 50%.
Thanks for watching. Remember to subscribe.